Association of Engineers. He is also an associate member of IRED, Institute of Research Engineers and Doctors. He is a patent holder. He has been granted 3 patents. He was awarded the Sir C.V. Raman National Award in 2018 under Young Researcher and Faculty category from IGRP Group. He is editor of special issued journals Computer Materials and Continua, Intelligent Automation and Soft Computing, and finally, Cognitive Neurodynamics in Springer in Scopus. So it's an honor to have such an accomplished person among us. Thank you, sir, for accepting the invitation to deliver the keynote speech today. Thank you.
Thank you so much, ma'am. Thanks a lot. First of all, I would like to, I would extend my thanks to college management, National Engineering College, then Dr. L. Julius, who has approached me through a common associate. Head of department, sir, please accept my gratitude. So thanks everyone for having me here, and I would like to be always on a discussion forum so that we could have explore more knowledge and more networking in a way, because we are in a new world of teaching and learning, because there are lots of e-learning platform is there, upgrade is there, an academy is there, so the things are not easy and the things are not that boring also, in a good way we can say that. So without wasting our time, we should start the session, which is on big data. Let me share the PPT with you, then we will have some discussion. It is not a lecture kind of thing, because there are many reputed and senior faculty, more senior than me, must be here. So I would like to discuss it, and I would like to get feedback from all of you. So I hope the PPT is visible to all of you. So I would request you to please.
Yeah, it is. Yeah, it is visible.
Okay. Fine. So this is it. We have to start with data streaming. Fine. In big data. The first question which comes in our mind when we are talking about big data, that what is big data basically, and why we are using big data if we are having everything like data mining and everything right from before. So we are using it. So why we are using big data now? What is the point? So this is one of the question I keep on emphasizing on. Apart from that, there are many other things which will come into our mind when we will go through, one by one. Fine. So let's start with it. So why big data? The first question I would like to ask you, why big data? So I would like to answer it just like why machine learning, why why there is a need of deep learning. So there are lots of things which is similar. So once we are having machine learning, so it is applicable. It has some limitation that it would be applicable on some this amount of data sets, this amount of data sets, and if data set is getting much more bulky, then the system will get changed. So before getting into streaming, we have to make sure that why we are going through with big data, and why big data is getting used, and why we should teach our student big data. That's the main question. So it's some other teacher domain also, some other teacher perspective also, some other teacher duty also to deliver the basics of big data. But the thing is, this thing needs to be discussed, that why we should opt to big data. That's my question is. So before getting into what is streaming and why we are using it, we have to discuss that why big data came into the picture and what is the use of this. Fine. So basically we were very good, or we were going very smoothly with the concept of data mining before. There are lots of other concepts like business intelligence and different other things. Apart from that, the things and the data become bulky in such a way that it is not manageable with those data mining tools and those simulators. So we need to have this big data tools and analytics? That's the simple question. If some student, who wants it to get it from scratch, we could convey this to him, that we have to manage a bulky amount of data. That's why we have switched to big data. That's the first question is. And not only managing those data, but to provide some efficient results as well. So we will see that how, I mean, we will use machine learning, how we will use recommender system, how we will in afternoon session I will give a very descriptive idea, the case studies, that there is a case studies asked that for tutor how it is getting done. But not only for tutor, we will tell everything, right from why Netflix has used it and what Netflix has brought into the picture. I mean, how they have revolutionized the whole thing. So we will see everything one by one. But before getting into it, we have to, I mean, we have to make sure that why big data is getting used, why we should read it. Fine. What is the point using this big data? So the data is getting bulky day by day, and the most precious thing and the most cheapest thing is data. I mean, it is freely available, even though it is precious. Fine. So everything we are telling, every word I am speaking, everything is becoming data. Fine. Whether it is data or whether is it information, that is the secondary part. But data, everything we are doing is data right now. So to manage those bulky amount of data, we need some good analytics, we need some efficient analytics or tool. That is what big data analytics I mean came to picture. And that is why we have to read it, and that is why we have to make our students aware of it, make our students educate about it. And there are lots of job, even in Amazon, even in Netflix, even in Hotstar. So there are lots of platform they are having. So everywhere they need a very good big data analytics. Fine. So I mean, without getting deviated from the right picture. So right picture is we have to follow the stream. So what is a stream? So stream, as you can see on the screen, that it refers to a sequence of data elements or symbol made available over time. But a data stream, according to me, is a existing, at the same time it is continuous, it is at the same time it is ordered. Fine. But how it is ordered? It is ordered in an implicit manner. That is the case, like implicit and explicit. So it is ordered in an implicit manner. So by the entrance time, or explicitly by timestamp, if we are getting it through, so it is ordered by the chain of items. Fine. So it is a very continuous process. So you can see on the second point, the data stream transmits from the source and receives at the processing end in a network. For example, I'm making it very simple. Suppose I'm sending you some message, or I'm sending you some mail, and it is basically consist of bits, or a stream of bits, like we are getting into some data transmission process. So even if one stream, or even if one bead has been lost, that is called data integrity lost. Fine. There is no data integrity in the process. There is no data consistency in the process. So that's my point is the same thing we can refer to understand what stream is here in data, in big data. So data stream transmit from a source. As you can see, there is a source and there is a sink. There is a source and there is a receiver which receives at the processing in a network. So we can refer to the same thing what we have done before. Nothing new concept is there. The approach is new only, even if big data is concerned. The same algorithm like SVM, the same algorithm, machine learning algorithm like clustering and other things will be used in the whole process. But the scenario, the parameters, the limitations will get changed. That's my point is. The first point, I mean, a continuous stream of data, what I have just explained to you, a continuous stream of data that flows between data source to destination, or source to receiver's end, and which will processed in real time. Fine. Now, what is meaning of real time over here? It should be associated with some deadline. Getting my point? It should be associated with some deadline. It should be associated explicitly with some timestamp. That's uh, the basic thing we have to manage. So if it is, I mean, if it could be hard real time or it could be soft real time. If it is soft real time, so missing the deadline will not, won't make any huge damage. But it is a hard deadline. Suppose train is passing, we must have gone through within a real time system subject during our MTech. So if a train is passing and if there is a timing that you cannot cross that line, I mean, if you cannot cross that particular lane when train is passing there, so that could, I mean, that could damage in a deadly manner, in a lethal manner. So that would considered under hard real time system. So there are two concepts: soft real time system and hard real time system. Mostly we are opted for soft real time system. As far as technology is concerned, we don't want to make it curse. Fine. So it's not like that we should have some lethal loss, some deadly loss. So that's why we will focus on soft real time system. So now, I mean, it is also refers to the, communication of bytes or communication of beats. Fine, that is, I mean, we have must have gone through the beat rate, baud rate, and everything, or any character over, a socket in a computer network. So basically, we are doing, or we are taking the things right from there. Fine. So a program uses a stream as an underlying data type in process of communication channel. Fine. So if we are talking about types of data stream, so a data stream basically is sequence of tuples. Fine. Whatever I have shared on screen, based on that, we can make our own definition, like it is sequence of tuples. What tuples we have gone through within an NLP also, what tuples we have gone through within in compiler design also, what tuples we have gone through within in theory of automata also. So each tuple in that case, or each stream, or each byte you can say, or collection of byte you can say, so each tuple comprised of sets of attributes. It should have their own sets of attributes. Fine. So similar to a row in a database table. That's it. When we are referring any database, so the same scenario will be happen over here also. And what could be the transactional data stream? If we are talking about what is transactional data stream, so we will see it one by one, everything we will see it. So when we are talking about transactional data stream, before getting into example or data stream application, we have to discuss the types of, data stream. What is data stream basically? The second thing is transactional data stream. So transactional data stream, it is just a log interconnection between entities. If we are referring database, we are again come to the database concept. So if it is database concept, we are again into entities part, like tuples, entities, these terminologies we have to go through with. So when we are talking about transactional data stream, it is a log interconnection between entities. Fine. For example, you must ask me this, give me an example that what is transactional data stream. So the best example is credit card. The best example could be telecommunications. So when we are talking about credit card, so basically purchased by consumers, by from the producers themselves. The second example I have told you, that telecommunications. So when we are talking about telecommunications, so phone call by the callers to the dialed parties. See, have you seen the data? I mean, this is called data streaming from source part to receiver part. So this is the basic, this is the basic thing we can discuss, and this is the basic thing we can start up with. Fine. Now the question is how we should, when we should, or how we should perform the measurement of data stream, how we should measure the data stream. So the first thing which will come into our mind, that there is a web technology, web we should use, accessed by client of information at the server. Again, the same example I'm giving you. So this is a client server peer-to-peer thing which will make the stream or data stream working for you. Then there is a point that what is measurement of data stream and how we can do the measurement of data stream. So there are lots of things. First of all, the basic thing which we have gone through right from our childhood, like right from our engineering days, that IP network. IP network is one of the way through which we can measurement the data stream. So IP network, that is traffic at router interfaces, we can say. The second thing could be sensor network related to it. So a physical natural phenomena, for example, road traffic. So for example, whenever we are visiting any mall, the gate are open and closed automatically. So how they are, getting to know this, that we are coming and we are going. So they are having a programmed thing that they are having a threshold that if anything which will having a weight of more than 40 kgs or 10 kgs, then you should get open and you should get closed. So it is trained like that. It is modeled like that. So that is called sensor networks. It can be used anywhere, whether it is road traffic, whether it is surveillance system, whether it is sliding window at any places, at airport or anywhere, in mall or anywhere. Then there could be the best case, which is a very sought to be research domain, that is earth climate. And trust me, it is not like that we should not go with machine learning and artificial intelligence into it. Earth climate, we should go for some, I mean, if you can see, I'm working my a postdoc thing in a renewable energy, in a photovoltaic cell. The concept of AI or concept of machine learning algorithms in photovoltaic cell or renewable energy or wind turbine or wind energy. So these are the things, I mean, even if you are doing research, it should have some real-time impact. It should have social impact. Otherwise there is no point in performing credit card fraud detection or something like that, like a BTech project. Fine. So let me give you another example of stream sources. That what is stream sources is, first of all, we will go through with the example of data stream application, what is there in your PPT. But PPT is very limited, so we cannot put everything into it. So it is saying the same thing, that monitoring and detection of potential failure of the system using network management tool, that is again IP and sensor network. Then there is a making data driven marketing decisions in real time. Again, real time is very much important. So it requires the uses of data from trend analysis of real time sales and analysis of social media and the sales distribution. As you can see, I'm telling you an example which we have come across, I mean, in our daily life. Suppose you have opt for some tickets, for flight tickets for your winter vacation or your summer vacation, and again you are searching it with the same email ID, with the same login credential, and you will get that there is an increase in the price. So that is big data for you. That is data mining for you. That is big data analytics for you, and that is why the e-commerce company is earning in a huge manner, in a huge way. So that is why we have emphasized on real-time system. It is real-time system. Suppose you have logged in into with your credential in a real-time system, the persons, the expert are there to, or the model is trained in a such way that they will get everything from your side, and they will analyze that this is Dr. XYZ and he has been approached this whole system, or he has inquired before regarding the holidays package or something like that. So we can ask for some extra amount and they will pay for it. You are logging into with some other credential of from your relative or anybody, from your relatives or any other login credential. You will get the price, varies from person to person, from login credential to login credential. So it is not like magic. It is like training system. It is like model system. So again, we have to jump. We have to jump to machine learning and modeling and deep learning concepts. But we are not supposed to do that. So we will basically go for the data stream application. Why data stream is important? Why we should do the data stream? So the third part is monitoring of industrial or manufacturing ministry in real time. So you can see it every time we are doing any kind of thing or any kind of application, we are using real time world. Fine. Again, I have talked about in a previous slide, I have talked about sensor network. So even though a sensor network or IoT controlled by another entity or sets of entities, anything, I have given you many examples. Then there is watching online video lectures and rewinding and forwarding them. That is also data stream application for sure. So everything which is supposed to be performed in a real-time system, which conspire of sensing networks, which conspire of online monitoring, which conspire of anything which is going online, or which is considering, or the things like data streaming, which is considering the things like byte streaming from source to sink. That is the example of data stream application. Always remember that. And we are seeing it on every walk of our life on daily basis. Fine. So application processing of data stream. So processing is in micro batches instead of processing batches. Fine. Just like we are trained to divide our students in different groups. Suppose some students have opted for big data analytics. Some students have opted for cyber security. Some students have opted for some other courses like Unix, or some other courses like Java, advanced Java. So we have, divided them in a group that's make the things more feasible, that make the thing more efficient. That's the main thing is. So processing in is micro batches instead of processing batches. It means that we cannot, take chances as far as data processing is concerned, because even if a small beat missing, the whole data or the whole data meaning can be changed in that case. Fine. So even if we are performing cryptography, even if we are performing some encryption decryption thing, so we have to make sure that the processing of data should be in micro batches to avoid any inconveniences. Fine. Then the second thing is processing of the streaming can be comprehended as filling milk in a bottle. Fine. So on a conveyor belt and capping them, everything right from the first point to last point, everything is important. So one at a time successfully rather than in a large batches at the same time, just to avoid inefficiency, nothing else. Fine. So if we are talking about sensor data, we have talked a lot about sensor data. So in navigation system also, suppose we are doing some navigation system, we are doing some case studies on navigation system. So in navigation system also sensor data is used. Fine. And imagine a temperature sensor floating about in an ocean and sending back to the base station like that. Fine. So a reading of surface temperature each hour will make the difference. Not like that we have done the things and we have to slip now and we have to do nothing now. That's not the issue. Is that's why it is totally real time oriented. That's why it is totally real time system oriented. So it is having some real time impact. Fine. So the data generated by this sensor, what I'm talking about, that a sensor or temperature sensor in an ocean we have done. So the data generated, whatever the data will get generated from this sensor in a stream of real number. Fine. So suppose we are having some 3.5 or 4.5 or 5.5 terabyte arriving every day, and we for sure need to think about what we can kept continuing and what can only archived. So these are the things which tends to move all the technologists and tends to move all the technocrats towards big data despite of any other technology, because the data generation is such we cannot opt for anything else other than big data. You can opt for some other tools and applications, but the concept would be, the algorithm would be big data only. So that's my whole emphasis is on that, why we should opt for uh, big data only. Fine. So suppose I'm an image data we are having. So I'm basically done some work on image processing. So I'll like to discuss it with you. Suppose we are having some image data, and which is not like a data set of having a disease data set or something like that. A huge data set like satellite imaging. It is in itself a very good topic to pursue our research. So satellites frequently send down to Earth stream, right? So streaming example, just have a look over it. So whenever we are talking about satellite, so it frequently send down to Earth stream. Fine. So it will contain many terabytes of images. You must be agree with me over this. And it must be containing terabyte of images, and it is on per day basis. It is not like monthly or yearly. It is on per day basis. So surveillance cameras in that case generate images with lower resolution than satellites had actually sent. Now getting my point. Am I clear what I'm trying to convey? But there can be numerous of them, each producing, may each of them will produce a stream of images at break of 1 second each, or even though of the fraction of second, isn't it? So if something like that will happen, then how you will manage those data, even though it is image data, even though it is sensor data? I'm telling you a very connective example. During COVID, there are lots of side effects inside our body. So the doctors used to keep sensors for 25 hours, and small IoT sensors, and they take the data that how our heartbeat has been performed, how our kidney has been performed, how our liver has been performed, how our whole body internal system has been performed through that data. So in each second, those data produced bulky data, but it is now very much possible to analyze all those data and to get at some result. So actually they are performing decision tree algorithm. They want something to analyze and to reach at some decision, even though it, if it is doctor, even though it is done by some researcher, the same thing has been done. Fine. So a satellite image processing or the satellite imaging could be one of the thing in data streaming model. So streaming in data in motion, three approaches for updating the endpoints. Endpoints means we are considering sync over here. So the first thing is non-overlapping. I'm telling you why. The second thing is slow batch processing, and the third thing is fast near real time. Fine. So non-overlapping will make the things very much efficient. I'm telling you why. Suppose we are doing this particular meeting or this particular FDP for getting something discussed from our side and exploring the best result out of it. Suppose there are person who are not comfortable in English, or who are not comfortable with the regional languages as well. So even if I'm performing this FDP in Japanese, it would be noise for everyone who is not very much comfortable in Japanese. So even though data is getting streaming, the data is streaming when the application part is zero. Fine. So this is not the example of actual, overlapping. Suppose some other person who is starting asking question in the middle, and then the stream of the data from his side or her side or from my side are getting overlapped. So it will become noise only. So understand in that way. That will be much more, easier concept to pursue. Fine. So overlapping can never be entertained in any cases. So overlapping is something which makes the data invaluable, which makes the data very much error, very much noise. There is no mean to pursue in that manner. Fine. So application of data stream could be, I have just told you that application of data stream could be anything, like fraud perception, like real time good dealing. Fine. So anything that can be we have gone through within our daily life. Consumer enterprise to the, like business intelligence is one of the thing, like observing and describing what is getting done inside current scenario of trading, current scenario of e-commerce. So we are having different topic or different domain to pursue the things further. So for now, non-overlapping means the data should be streamed in such a way that there should be no noise. I mean, we should go for pre-processed data. That's my whole thing is. The second is slow batch processing. I have just told you that you have to divide the things, divide the stream in some, classified things, so that we can able to judge that which stream is getting done better, which stream is not getting done better, which stream is exactly delivered like it was sent from the source end. If it is not exactly delivered, then the message is getting failed. You must have gone through with, if we are considering data stream capability, you have must gone through with the happened before relationship concept. We all have gone through with this in a distributed file system or distributed system. Happened before relationship is like that. Suppose I am a source and you are a sink, and I have sent you messages like, right, an hour ago I have sent you message. After me, some other people has also approached you and they have sent message. So their message has been reached to you and my message has not been reached yet. So my message, even though it was sent an hour ago compared to others, but it is considered to be failed transaction or failed messages. Fine. So a sender will always happen before the receiver end, that is happened before relationship. But even though if the message has not been transacted well, if the message has not been sent well with all the data stream what it was sent from the source end, it should reach the sync part. It is a failed message part. It is an efficient data transmission. Fine. So these two concepts like non-overlapping and slow batch processing are very much important. Fast near real-time system means we have to go for meeting the deadlines. We cannot miss it, even though the things are bulky, even though the data sets are bulky, we have to go for it. Fine. So these three things we need to always consider while we are while we are dealing with these things. Now there are some other concepts also which we need to discuss, like different ways of modeling data stream, querying, processing, and management. So query processing is very much important, right from database also, database management system and everything. Fine. But here we are more here to describe the advantages, describe the applications. So applications I have already been discussed with you, so you can see this. We have to discuss in a noon session that graph based streaming data, but we have to discuss it more like graph analytics. Here we are trying to convey that graph based streaming data model for processing at an operator or adapter. So right from source to sync, there is a operator or there is an adapter in the middle. What adapter will do, if there is some data stream lost, it will manage to get those. Even if it is lossless data, even if it is lossy data, they will take care of it with maximum of their capabilities, and then they will let reach all the stream which has been traveled from sources. So this is the basic scenario we are having. So on the basis of it, what is, we have gone through with applications. What are the advantages of data stream? Why we are reading it? The question is like that. So see, the data is traveling from one place to other. They're having bit rate, they're having baud rate. It could be anything else. These particular data is helpful in upgrading sales, actually, if it is business intelligence. This particular data stream helps in recognizing the fallacy. flaws, frauds. This will definitely help us to minimize the cost. Even though customer can, compare the things from different e-commerce website. That could be the one of the example. Fine, but here we are not talking about customer point of view. Here we are talking about technical point of view. So it helps in minimizing the cost when we are performing those things. Fine. Now there is, before getting into some more results, now there is a relation-oriented stream tuples model. So what is relation-oriented stream tuples model? We must have to go through with this. So stream data flow can be modeled as tuple flow. I have explained it before only. It can be considered as a tuple only. Fine. Now, what is the point if we are talking about what is the point why we should use it in apart from this minimizing cost and policy? So the main point, according to me, if you will ask me, it provides details to react swiftly to the risk. Fine. So risk factor is managed very well by using this data stream policy. What could be the disadvantages? The disadvantages could be, so that everything is getting online, the disadvantages could be lack of security of data. Lack of security of data in which manner? Lack of security of data in cloud mostly, we can see. Fine. So basically when we are getting into it, it hold the cloud donor subordination. Fine. So these are the basic disadvantages of data stream. Fine. So off premises, if we can see warehouses of details. Fine. So introduces the probable for disconnection. It could be the another thing. So there are lots of things. So that's why on your screen also it is getting that streaming data flow can be modeled as tuple flow. Fine. The second thing is individual data items may be relational tuples in a data stream model. They might be relational tuples. It is not mandatory, but they might be. Fine. Timestamp will always associated with those, just like in operating system when we are performing pipelining, when we are performing job scheduling. So if we are talking about real-time system, there should be timestamp or key values must be associated with the things. So as you can see over here, there is a source stream, there is a sync stream, and data stream has to be traveled from source to sync, but on every step, big or small, on every step, what it is getting done, the data is associated with keys and value just to show the attributes, because I have told you that each streaming bits is having their own attributes. They must be related with a common associate, but they are having their own attributes. So a data stream, as what it is showing in this in the slide, as an infinite time ordered, means associated with timestamp, multiple set of tuples. Fine. So how it is dispatching from source stream and how it is reaching to the sync stream, that is the whole relation oriented stream model for you. Fine. So it is not that much tough, it is not that much new. Everything has been covered in machine learning concepts, everything has been covered in data mining concepts. We have to just exaggerate the things for bigger data set now. Fine. For bigger data sets, so we are having some bulky data set to analyze. That's the whole thing is. Now this is a data stream we are having. So an unbounded, a time ordered must be there. So an unbounded, a time ordered. So as you can see over here, these things are always there. Fine. So time order. Why we are emphasizing on time order? Fine. Why we are emphasizing over the time order? Because it is a real time system concept. We have emphasized over it. Fine. It is a sequence of data items. I mean, relational tuples. So we have all discussed this also, relational tuples. Fine. In a data stream model, something like that. Fine. So there is no concept that we are supposed to minimize our data set or we have to reduce the dimension of our data set. We have to manage all the data set in the same way, but we have to perform pre-processing. Fine. Then there is a second point, the receiving software receives the sequence of order and sees the data items only. Fine. It will focus on data item only. Always consider. So each tuple consists of set of attributes like a row in a database table. So the tuples have schema like. So schema we have gone through within DBMS, database management system, right or wrong? So sorry. So we have already been gone through with that. Fine. So we need to cover one thing, that when we are talking about streaming data or data stream, we have to go through with the architecture of data streaming. So now we will discuss what is architecture of data streaming. Fine. So just have a look over it, how each tuple is getting considered, everything. So you all are having everything on your computer screen. I'm just explaining it. So first point is each tuple consists of set of attributes. I have explained to you like a rows in database table. So now architecture will get it through with this means only. So this is we are having, and it is having their own set of attributes. So this thing need to be considered every time. This will make your things easy and you can get it reference from the I mean DBMS, and you can understand it better. So the last point I want to I mean discuss with you, then I will come to the architecture part. So one of the attribute in the tuple schema is in timestamp. So again, timestamp is there for you. You cannot skip it. Timestamp is missing, that means you are wasting your time. It is not working in a real-time system. That's the whole point is. So now we can able to discuss what is data architecture or data stream architecture. So basically, on based fact, what we have discussed, I will discuss my opinion only on the fact which we have discussed before. So streaming data architecture is a framework basically. You can tell, you can say it like framework, or you can say it like model. Fine. So it is a framework or model of software, right or wrong? So it is a framework of software or it is a model of software components, of course. So it is basically built to ingest and process large volumes of streaming data. I have always been focused on large volumes of data. That's why we have uh, opt for big data, large volumes of data. But it is not as easier. It is not like array homogeneous collection of data. It is heterogeneous. I mean the data from multiple sources. So it need to be pre-processed in that efficient manner also. You should have your own data in that way that you can process it or you can apply your algorithm over it, but it should be compatible with the tool. So you have to work hard for making it compatible because it has been collected from multiple sources. So while traditional data solution basically focused on writing and reading data in a batches. Why it is in batches, I have explained it to you. Why we have processed our students in batches, I have explained it to you. So a streaming data architecture consumes data immediately as it generated, persist it to the storage. Fine. Very simple, and may include various additional components as per use cases. So we will see the use cases. So basically, streaming architecture needs to be able to account for unique characteristics of data stream. As you can see over here, as you can see, this is attributes. They are having their own attributes. That's why I have highlighted this. Those attributes termed as unique characteristics, which makes it different from each other. So which tend to generate massive amount of data. The massive amount of data means it could be in terabyte, it could be in petabyte, it could be anything else. So that is, that it is at best semi-structured and requires significant pre-processing, fine, and ETL to become useful. And then what is ETL? The same concept which we were having in business intelligence and data mining. That means entity, transform, and what is L for? Anyone can message me if we have gone through with this. Anyone?
So participants can unmute.
Okay. Okay. You can message me also, so it could be much more interacting. Rest, I hope this terminology has been clear. One or two more points, if I'll get in my mind, I'll discuss it with you. Before data source and sink, we can go through that stream processing. That stream is processing from data source to sink only. So stream processing is in itself a very complex challenge. It is not as simple as I'm discussing. So it can be rarely solved in a single database or with a single tool. Fine. Hence that's why we need an architect. Or a solution architect. You must have gone through with this post in different corporate companies, that solution architect. So we need that solution architect. Fine. And they are having some solution which consisting of multiple building blocks. Fine. So building block can be combined and replaced with declarative functions with the platform. And then we will demonstrate how this approach manifests with each part of the streaming data supply chain. That's the whole scenario of working is. So basically, when we are talking about the components of streaming architecture, so most streaming stacks are still built on an assembly line of open source and proprietary solutions to a specific problem, such as, for example, take stream processing, for example, storage data, for example, data integrity. That means integration, real-time analytics. If it is not done in real-time analytics, suppose you are sending some information to the students regarding a student workshop, or regarding sessional which has been scheduled on a short notice by tomorrow, but they are having 5 subject, and you have sent them 5 subject schedule, but they have received only 4 subjects schedule. And if the 5th subject schedule will reach after a day, that is data integrity loss. There is no point of getting those data. Fine. So data integration and real-time application is very much important, and it is very much connected itself. Getting my point? So there are lots of examples we can take from our daily life. Suppose uh, we are having some modern platform that combines most building blocks and offer a seamless way to transform data stream from source to sink, as we are talking about data source to sink. So the transformation of a stream into analytics on a ready data set is not very much tough. But if data set is being collected from multiple sources, you have to work over those data sets to make it compatible. For example, I'm telling you, if you are having any program in Notepad, if it is saved in C, or if it is saved in CPP or C++ extension, so the executable file can be run in that particular compiler only. That's my whole point I want to convey to you. So we have to make the things compatible. We have to make the data compatible with the platform. Whether you go with modern data lake platform or traditional patchwork of the tools, that is not mattering. Your streaming architecture must include, I mean, building blocks. That's for sure. That is what building blocks is all about. Fine. So what are those four building blocks? We will discuss it one by one. What are those four building blocks? First of all, we will see that how data source is getting done, RDBMS row oriented message. Fine. We have discussed that nested column oriented data. So that's why I have told you that we have to divide it in building blocks. Then there is nesting sequence is a table, row group, column chunk. We have to work on page chunk, like page fault we have gone through with the concept, with the column chunk. So there are many things in which we are performing batch processing, in which we are going for building blocks. Fine. So object based data stream is another thing which we need to be discussed. So data flows model as an object. So Cougar and Tribeca object based data stream are the examples. You will definitely go through with this when you will teach your students. So Cougar model sensor data as a stream of object only. So it is very much common and it is very much used. Tribeca model, the network monitoring data as a stream of object. So there are sensors, there are monitoring data, which we have already been discussed before, that these things are getting happened. Fine. So there is a concept of XML based data stream model also. Fine. So there are lots of example of that, but that would be a separate chapter if we have to go through with this. Getting my point? So a separate chapter should be done for XML based data stream model. But before that, we have to go through with the four building blocks. Basically, four key building blocks we are having. Then we could able to understand XML based data stream also in a very efficient manner. So the first one is message broker stream processor. Message broker stream processor. Fine. So message broker stream processor, we have definitely gone through with that adapter part and that thing. But before that, we have to consider that there is a sink, or there is a source, or there is a sink, and in between there is an intermediate. Even though we are talking about process and any system, whether it is education system, whether it is computer system, whether it is process system. So system is doing what? System is taking input and system is processing it and system is getting output. Whether it is police system, whether it is education system, the system work is done in a very similar manner. The generalization can be done like this, that it takes input, it process that, and it provide you output. Fine. Similar way, the message broker stream processor is the first building block. So this is particularly the element that takes data from the source, right? Let me reach to you this model. Suppose these are having some uh, intermediate and these are having some source stream, these are having some sink stream. We have already been discussed that Parquet nested column oriented of RDBMS or tabular store, or it could be row wise, it could be column wise, it could be row chunk, it could be column chunk, anything else it could be. So, I mean, the element which takes data from the source, they are called producers. They basically translate it into the standard message format. Fine, if I'm not wrong, and streams it on an ongoing basis. So it will be done in a nested manner, means again and again. So other components can then listen in and consume the messages passed on by the broker. That's why it is called broker. Fine. That's why it is called broker, message broker. So other components can then listen and at the same time they will consume the messages passed on by the broker. That's the thing is. So the first generation of message broker, for example, you must have heard about Apache ActiveMQ. You must have heard about Rabbit MQ. So they relied on message oriented middleware, that is called MOM. Fine. So these concepts
Abhishek? Abhishek, can you hear me? Abhishek sir, your voice is not audible. I think there is some problem with the connectivity issue. I think so. Participants, wait for a while. Just check it out with him. Abhishek, on the screen has been changed, but the voice is not audible. Participant, sorry for the interruption. Interruption. I think he has some network issue. So
Am I audible now, Dr. Jules?
Yes, yes, Abhishek sir. Now you are audible.
Okay, I don't know what went wrong because I was in the middle of it. I was completely, going through with it actually.
While you are sharing the block diagram,
Okay, okay,
the system has, I think, network issue. I think so. It was stopped and screen also not moved. Any voices also not here. In the
okay, okay.
slide
I
number
got
10,
it.
10. Yeah.
I got it. I guess some call came in between, and that's why there is
Yes, yes.
I rejected that call. Okay,
Okay, okay.
okay. So let me start with it. Not an issue.
Abhishek, we have a question also, Abhishek.
Yeah, please go ahead
Yeah,
so that we
yeah.
can have those session. Yeah, done.
They have asked what are the critical relationship types found in data model?
What are
What are the critical relationship types found in a data model?
critical relationship types means in which way? If we are, pre-processing it, or if we are working over it. If it is, we have to check that whether we have collected it from multiple source or whether we have get it from the same source we are having. That's we have to consider of when we are considering those data models. Fine. So basically we are supposed to make our own model. This respect, we are taking some thing in a case we have to cover those entities or cover those anomalies when we are dealing with those data models.
So they are asking with multiple source only.
I'm not getting, sir.
Ah, they are dealing with multiple source only.
Okay, they are dealing with multiple sources. If they are dealing with multiple sources, we can go for different pre-processing techniques, because we are having ETL before that. But apart from ETL, we are having different multiple technique. If we are talking about multiple source collection and multiple source thing in if we are dealing with data modeling. So when we are talking about big data modeling, we have to cover bulky of data. That means on daily basis, on minute basis. But when it is from different sources, then we have to always consider for pre-processing part in a most convenient way. But many season, data engineers, basically, if you are talking about in case like we have to process it or we have to make students implement about it, then we should must cover that the dimension of the data modeling should be simple. This should be organized data in such a way that it is quick and easy to understand. So there are lots of basic things which we have done in DBMS and RDBMS, sir. But if you will emphasizely tell me that what we are trying to get from this, then I'll able to answer it specifically if it is not working for you.
Okay, Abhishek, we'll have this same question in the end. Okay.
Okay, done,
Okay.
done,
Okay.
done.
Sure. Done.
Any other question we are having?
Participants, do you have any questions? Kindly unmute yourself and you can ask, or you can use the chat box also. Please. Abhishek, let's continue. We'll have 5 minutes in the end of the session, Abhishek.
Okay,
Because
okay.
we are
So how
running out
many
of
we
time.
are how much time we are supposed to have, right? Like for this session.
Another 10 minutes, Abhishek.
Okay, done,
We'll get,
done, done, done,
exactly finish at 11.
done, done, done. So
Okay.
let me share the screen. The screen is shared with you. I'm sharing it
No, no,
again.
Abhishek.
I'm
Not
sharing
it.
it again. Not an issue.
Yeah, okay.
Let me share this. Is it visible now?
Yeah, it is visible, Abhishek.
Okay, okay, okay. Wait. Yeah. So here we were at, like on this slide, XML based. So before getting into XML based, we have to consider that big data stream computing thing. I mean, what it is and why we should use it. So stream computing is a way to analyze and process big data in a real-time scenario. So real time, I mean, it is very common now. So we have to more focus on the stream computing application and where we have used it. I mean, why we have used it and where we should use it. That is the more coefficient way. So let me share it with you that how we should use it and what application we could go further with. So if we are talking about the message broker we have discussed, so apart from that, there are many analytical tools which are in the market, which are in the sector, but these are expensive. I mean, these are not very much easy to use. So whether it is Elasticsearch, whether it is Amazon Redshift, whether it is Amazon Anthena. So it is basically based on distributed SQL engine. So the question you have asked also, that the database model we have to opt for, or the database model we have to go for, even though they are have been selected from multiple tools. So we have to go for basically the basic concept what we have done in SQL, or what we have done in RDBMS, or what we have done in I mean Oracle query or anything like that. Fine. But apart from that, these things are basically done in a distributed system manner. Like we have to take the things from different sources and merge it and make it simple for a basic solution, just like we have done in I mean divide and conquer thing like that. Fine. So streaming data storage, even if we are considering it in a database or data warehouse, for example, PostgreSQL, right, or Amazon Redshift we are having. So pros and cons both are associated when we are dealing with it. We are having pros also, we are having cons also. So easy SQL based data analysis is one of the very good advantage, but at the same time when we are having cons associated with it, so it is very hard to scale. So even if you are going for data model, it will definitely very much hard to scale and manage. That is for sure. Any kind of data model you want to go further with. But if it is cloud based, then the storage will be expensive. Even though we don't have anything to, I mean, analyze the data on cloud based on an open source, which is very much effective. Even if you are doing your PhD thesis or MTech thesis in that, so it is very much like that. Apart from that, when you are considering message broker stream, so it is also having advantages associated with it, and it is also having disadvantages associated with it. How it is, how advantages it is, it means it is agile. I mean, it is having no need to have a structured data into tables, easy to set up. Fine. So the disadvantages could be again the complexity. The data source is very much fine, so complexity would be very much big. So that's why when we are supposed to having application of stream computing, there we have to based, or we have to bank upon these terminologies only, which are having advantages and disadvantages associated with it. Fine. Now if we consider something like Amazon Kafka, fine, so data retention is an issue if we are supposed to have Kafka storage. Fine, and it is 10 times much more expensive than what is existing in the system. So we should not go for those also. So if we are going for Amazon S3, if we are going for data lake, something like that, even if those part are also expensive, high latency is there. Fine. Difficult to perform SQL based analysis in that way. Fine. But at the same time, it is comparatively low cost storage. It need no structure and no tables. That means it is also agile. So these are basic things we are having, that we are going with. If we are going with data lake, is the most flexible and inexpensive option we are having right now. So data lake could be one of the factor, but it is I mean, if it is related to high real-time system, it is not best for that in that scenario. Fine. So we have basically mentioned that before about the challenges of building the data lake and maintaining, data storage, including the need to ensure exactly once it is getting processed, partitioning of the data, enabling the historical data. Fine. So it's easy to jump, or it's easy to dump all your data into object storage. Creating an operational data lake can often be much more difficult. So that's why, window based data stream model is there. So streaming data direction can be toward fixed window or sliding window. So if we are talking about sliding window, we are having a very, a quick thing like sliding window, that like stock data prediction. So it is basically on sliding window part based. Fine. So there is a data stream architecture and there is a modern stream architecture which is totally based on the previous one. But the benefits, I can tell you, that is very much better than the comparatively with the previous one. That the modern data streaming architecture can eliminate the need of large data engineering projects. The first advantage could be that. The second could be the performance. So high availability and fault tolerance, we all have gone through within a distributed system or distributed algorithm. So that is the main strength of modern streaming architecture. Another we can add, but it was in previous one also, that the newer platform, the cloud-based platform are added into it and can be deployed very quickly with no, upfront investment. It is come basically with the in a package. Then there is flexibility and support of the multiple use cases. So these were the drawbacks what normal data streaming was having, and which was, overcome by the modern data streaming architecture. So if we are talking about architecture or modern architecture, Amazon Cloud is there, Amazon Kafka is there. It is example of modern streaming architecture. AWS. Fine. Since most of the customer work in streaming data. Fine. So we encounter many different streaming use cases, most around operationalizing Kafka. Fine. So we will find, or we can find some case studies and reference architecture that can help to understand how organization in various industries design their streaming architecture. Fine. So there are lots of things. They're like real-time machine learning at big bid. Fine. Like we can take a case studies of Twitter. We can take case studies of Hotstar. We can take case studies of Netflix. Fine. Totally a pure example of big data or streaming of the data. So multi-purpose data lake can also be one of the way. The future of streaming in 2019 and beyond, we can say that it is really revolutionized in this era. So streaming data architecture is constant flux actually. So I mean fast adoption of platform is one of the strength, that decouple storage and commute uh, lakes, which increasingly efficient the provide efficiency to the result. Fine. So the result could be of any type. Fine. So the first category, as you can see on your screen, the first category is probabilistic sampling. Like there was a probabilistic approach, probabilistic algorithm, and there is a non-probabilistic algorithm. So nothing has been changed basically. We have to stick to the conventional part, but we have to make ourselves efficient, or we make ourselves upgraded in approach only, in tool wise approach only. We need to have a better knowledge of tool, how we should use it. The concept is not very much different from the previous one. The first category, you can see we have gone through with probabilistic sampling, we have gone through with non-probabilistic sampling. So if it is non-probabilistic sampling, uses arbitrary and purposive sample selection instead of sampling based on a randomized selection mostly. So whether it is randomized or whether it is probabilistic, that's my point is. Fine. So there are lots of other methods also, like concise sampling or other things, but we should focus on that. What is the future trend which tends us to follow these things? That how we should go for the future trends? What should be the future trends? So 3 or 4 points which is in our mind. So get the overview of common options for building an infrastructure. The first thing is whether it is concise sampling, whether it is anything else. Fine. The second thing, even if you have to manage that, see how to turn the event stream or any kind of stream we are performing into analytics ready data. These things, I mean, the second point I have told you, these things need to be taken care of in selecting a data model also, or making a data model also. So basically when we are doing, I mean, cut through some of the noise, how we will cut through the noises? By pre-processing of the data. That's what I have said, that if you are taking the data from multiple sources or similar sources also, pre-processing is a very important step. Sampling is a very important step. Quantization is a very important step in a prerequisites phases. Fine, then you are able to work and get a very efficient result in that manner. Fine. The last point you can say with, I mean, you should have some concrete ideas that what we have to do, whether you have to deal with your data model, whether you have to deal with the data streams you are having. So you should have a concrete idea for what you want from it. Fine. So only automation will not work until or unless we are having some basic concepts like RDBMS, structured query language. These things need to be there only. Fine. So there is a concept called automation of data plumbing. So it is also very important. So organizations are becoming reluctant to spend previous data engineering time on data plumbing. Getting my point? So instead of activities that add value, such as data cleansing, such as pre-processing of data, such as enrichment, increasingly, I mean, data teams prefers full stack platform that reduce time to value. And these things should be considered in data modeling part also, in a very conventional or unconventional manner. These are the basic things, funda. Fine. So with now, I mean, if you are having any question regarding the transitioning of data warehouses or data lake or the future of streaming of data, then you can ask me, and we will discuss it more in a next session if it is very much clear to you. So you can ask me question if you're having. I'm waiting for your questions. Am I audible to everyone?
Yes, Abhishek, you are audible.
Yeah, so there is a question. If there is any question, because we are having short of time, we can discuss it on, I mean, filtering of a stream also. So we are having examples also. So why we are needing it? We are just needing it for pre-processing part. So once it is getting done, we can have work on our data. I mean, we can apply algorithms over it. So that's the basic thing is. So apart from that, you can ask me question what we have gone through with so far.
So participants, you can unmute and you can ask your questions.
Actually, I'm not able to hear because, sir, there are lots of noises.
Participants, any queries? Participants can unmute your mic and you can directly ask or use the chat box for your questions. So as already mentioned, this is the platform for knowledge sharing. So how much amount of questions you raise, it produces, because the experts are very knowledgeable in this domain and they are ready to answer whatever the queries you ask. So it will be a good understanding to build a good research community. So I request the faculty members who are interested, you can raise your queries so that we have a good interaction sessions.
We can have a query session in other two
Yeah. Yes,
also, because
that's what
yeah,
I also thought.
we can have a better case
So
studies in that, so we can have a good number of
so
questions in there
Abhishek,
also.
we break the session here at 11.
Okay.
Now the time is 11:03. We'll break the section here,
Mhm.
and we'll have some break, and we'll see in the afternoon session, Abhishek.
Done. One
Okay.
one one request to you.
Yeah.
We can continuously make the both session done. We won't take any break in that session, so that the
Yeah.
things.
Okay.
Okay,
I'll
na?
make the
So
arrangement accordingly.
okay, done.
Okay, Abhishek.
Done. Thank you so much.
Okay,
Thanks everyone.
thank you, Abhishek. We'll see you in the afternoon, and
Done.
Abhishek
Done.
is handling another two sessions in the afternoon. So I heartily congratulate Abhishek for accepting our sudden.
No, it's pleasure,
Request.
sir. It's pleasure. Honor
Okay.
is such an honor. Thanks so much.
Yeah.
And we
Thank you
will,
so much,
yeah,
Abhishek.
yeah.
We'll meet in the afternoon, Abhishek.
Done,
Thank
sir.
you.
Done, sir. Thank you so
Thank
much.
you.